Cool, welcome back to the Open Programming Miniconf. Hope you had a good lunch break. Before we get started with talks, lightning talks, sign up on the wiki. We want to see heaps of lightning talks at the end of the day so that we don't finish early. I didn't schedule talks then so that people could do lightning talks, and people aren't signing up for them now, so you better get and sign up for lightning talks. Well, go on, register yourself. So our first presenter after lunch is Malcolm Locke, who is a resident of Christchurch. Last year he put in his biography something about earthquakes. He didn't put it in there this year. So he's going to give us a talk about the JavaScript testing toolbox. Please make him welcome.
Thanks everyone. As Chris just said, my name is Malcolm Locke. I'm a consultant and web developer and sometimes sysadmin from Christchurch. Those who know me know I'm a bit fanatic about TDD and testing, and the first point I want to make is, what the heck is this guy doing at Linux.conf talking about JavaScript? We only talk about real programming languages at this conference. The thing about JavaScript, it's not necessarily, for most people, anything that we set out at the beginning of our career to learn as our primary language. It's almost anybody. Can anybody who has ever written any JavaScript put their hands up in the room? I think that's everybody, basically. Maybe one or two exceptions. It's something that basically, if you ever do anything on the web, you're going to have to write at least 1 or 2 lines of JavaScript. That JavaScript code is rarely ever tested. For the reason I said earlier, it's not generally your primary language. It's not something that you tend to take too seriously when you first start doing it, but the demands of your JavaScript code will quite often escalate. Most people's JavaScript, certainly mine up until recently, is not very well factored. You tend to write huge pages of jQuery nonsense, just on an ad hoc basis, and it's very difficult to approach because this is all browser-based code. It's hard to approach with the same mentality that you'd approach Python or Perl or Ruby code testing. It is really important, though, if you're doing more than a tiny bit of JS, to actually try and test what you're writing. You've got a colossal variety of platforms and implementations that you're targeting when you write JavaScript code for the web. Probably the most widely installed interpreted language in the world. Wherever there's a browser, pretty much, there's going to be a JavaScript interpreter there. So that's a lot of installations. It's really helpful to have a JavaScript test suite to aid you in debugging problems. If you've got good coverage for your JavaScript code, you can usually and somebody's having a problem with their particular combination of versions of software that they're using, you can just point them to the test suite and say, tell me what this shows. And usually it will give you a better indication of the error than just the app's not working for them. And the JavaScript code is getting more and more complex every day that we write. It's really become the de facto language for sort of client-side implementations for web pages. There was a time back in ancient web history where Java applets were supposed to be the thing for client interaction. That never really took off, and JavaScript has taken over that role. And also there's the emergence of things like Node.js, where people are writing JavaScript server-side, and obviously you're going to want test coverage for that. I'm just going to demonstrate a few tools and use the simplest bit of code I can to demonstrate how you test using a few tools that are out there. It's by no means the complete list of tools, it's just a select few. So this is the piece of code I'm going to do, just to add 2 numbers together function. The first tool I'm going to talk about is QUnit. It's written by the jQuery team, and it's actually used by jQuery's test suite itself. Because of that, it actually requires jQuery to run, so it's not necessarily the best choice if you're not using jQuery. It doesn't have spies, mocks or stubs, which I'll talk about later. But it has got some good tools if the code you're wanting to test is really just about DOM manipulation and adding and removing elements from the page. To get started using it, you have to run this code in the browser. So basically, to rerun the test suite, you open it in the browser and you hit reload, and that's how it works. And you need a little piece of HTML scaffold to actually run the code. That's basically the bare minimum there, including the QUnit JavaScript, including the adder.js, which is the code I'm wanting to test, and the actual test suite that I want to run. And that's what the basics of a typical test is going to look like. We've got a module block there which does any setup and teardown you want to do before each test runs. This is going to be familiar if you've done unit testing in any other languages. I've got a test there that's a good one. It expects the answer of adding 2 and 2 to equal 4. I'm saying expect one test, so if only more or less than one test is run after that block of code, then something's gone wrong. And then I've just put a broken test in there so that we can see, this is saying, checking that 2 plus 2 equals 6. So that, I don't know how readable that is for you guys, probably not very good. How's that? So that's the output of that scaffold web page after you run the tests. Normally, you'll just see a big load of blue lines saying everything's fine and it all worked. If you get any failures, you get a nice little description of what went wrong. Quite handy for debugging. There's also a couple of options up the top there. No globals, which will notify you if you leak any global variables into the global namespace, which is quite easy to do in JavaScript. And no try-catch, which basically normally the tests run and wrap the whole suite in a try-catch block. That will stop it doing that, which can help you debugging the tests again. You get all of these assertions available, so for just checking various expectations on your code. The tools for testing DOM manipulation are quite handy in QUnit. You can basically create an element on that scaffold page with an ID of QUnit fixture, put the markup you want in there to test, and that markup element will be reset to the pristine state in the page that it was in the static page every time each test runs, which is quite useful if you're adding 500 elements. It'll just get reset back to the beginning again. Here I've got an example how you'd implement that. I've just got an empty UL in there. I've got a bit of code that adds a list item into a list, and then I can test that just like that. And by just using normal jQuery functions to check the length of the list after I've called the test should be 1, and then this second test at the bottom is just proof that the element will be reset on the next test run, and that's actually running as an iframe in the browser, so that's not a screenshot, it's actually running the test. Then that's basically, it's quite a good, if you're using jQuery and you want a basic XUnit style framework, QUnit's a good choice. If you're not using jQuery, you might have to research around a little bit for other ones. I can't really recommend a different one. Jasmine is it's a BDD style, so it's generally supposed to make the test slightly more humanly readable than a XUnit style. It has spies, stubs, and mocks, which I'll show you in a little while. And it's not dependent on any other libraries like jQuery, so it's completely standalone. Needs an HTML scaffold, runs in the browser, same as QUnit, not really worth showing here, it's just an empty HTML document. That's what the same test would look like. And you can just see that the order of the tests make it slightly more expect this to equal 4. It's more like human speech basically, and it generally easier to read. That's what the test runner looks like. Normally you'll just see a little tiny green element at the top where it says 2 specs, 1 failure. That will be green and that's all it will show you. It won't show you a huge ream of all of the tests. It will just say how many tests run how many failures there were. Normally that will be green, but obviously we've got that intentionally failing test in there to show you the output. You get these matches. There's just a few of them, and there's a lot more available. Test whether something is truthy, falsy, whether it matches a regex, whether an array contains a value. You can also add your own matches, which becomes quite useful when you've got stuff within the domain of your application that you want to test. So here, any number over 1,000 I consider to be a big number, and I want to just write an assertion that that number's big. You can use it like all of the other matches once you've implemented that. Spies, these are basically, can behave like mock objects that you can check whether a function was called or not during the duration of the test. Allows you to, quite often your code becomes intertwined, and without loading your entire environment up, you generally only want to test one class or function. So it allows you to create fake objects to use in those tests, so that you're only testing the system under test, the SUT. And there's an example of how you've got a blog post and a comment, and the comments are linked to blog posts, and you're quite often going to have code like this in your comment prototype that calls this.post.getTitle. You don't want to have to load all of the other code up to do that if you're testing it properly. You just want to be testing this one, this comment class rather than the post class. This is basically how you create a spy in Jasmine. So it just creates an anonymous method, and you can just very succinctly describe how you want that method to behave. So, and I'm going to spy on the getTitle method on this object that and if it gets called, I'm going to return that dummy title string. You can also use it to ensure that a particular method on an object was called during the duration. So I've got a window.logger up the top there, which in my real application is going to be a big complex prototype object, but I don't want to have to use that in a real test. So I just create this spy object, and at the end of the test, after I've called post the comment, I just want to make sure that the logger object had the log method called with that argument. As I said earlier, no dependencies for Jasmine, which is quite good. You can nest the describe blocks, which is a really useful thing. You'll quite often end up in the setup block doing a lot of work, building up fake objects, and sometimes you just want them all to be the same except for two tests where one of the setup items is different, and the nesting the blocks allows you to do that. It's a very useful feature in practice. Next tool called Synon. It's not a testing framework per se, but it's just gives you a load of tools, so you can use it with QUnit, you can use it with Jasmine. Gives you some very powerful spy and stub behaviours, and it gives you this really cool fake Ajax server. That is tremendously useful, and I'll probably actually, because my time's running out, I'll skip through most of this to just talk about that. If you've got an app that does Ajax calls, you don't even have to have the server code written to actually start doing the JavaScript with this. You can define, basically, whenever that GET request is made to that URL, return status 200 with application JSON, and chuck this JSON back to the JavaScript code. So any Ajax calls that get made in the app get intercepted by this object. And another really useful thing is that the fake Ajax server doesn't respond to the request until you actually explicitly tell it to. So say you've got the classic example, user clicks on a button, an Ajax call's made, and a spinner class needs to be added to the button to show that it's loading. You can simulate a button press, check the spinner class, okay, yes, it's present, now respond, and check the rest of the behaviour there. So that's a really useful tool. I do use it quite a lot, and I recommend, if you do Ajax work, having a look at that. Other things, there's some good integrations with QUnit and Jasmine available just to make succinct usage possible, and the fake timers, which is quite useful if you want to test something like transitions over a certain number of milliseconds. You can actually just immediately fast forward the system clock 5,000 milliseconds or whatever, and then check some element has been removed from the page. Quite useful. I was going to talk about a couple of other tools, but I just wanted to show this one instead. I was going to talk about Selenium and JS Test Driver. This is a very recent tool, and it's really promising looking. It's from the same author as Sinon and another guy. It is very fresh. I've been trying it as I've prepared this talk, and it actually works quite well. Requires Node.js, and it combines a lot of features of QUnit and Jasmine into one tool, plus some very cool extra things. It doesn't require the HTML scaffold. It generates that itself, so you just have a config file telling it about your source files and your test files and where to find them. It can do the QUnit style assertions, or it can do the Jasmine style assertions with the same tool, so you can take whatever your preferred method. You can test Node.js code with it completely headlessly. So if you've got a Node.js project, just set the testing up and run buster test inside the Node.js, and it'll run from the command line in the normal unit test style. You can generate static pages like the scaffold page. Just set up a local server, and you can point a web browser to those and load it just like did with the Jasmine or QUnit. You can export those files to the file system as well if you want to put them on a server somewhere and say to somebody, hey, can you just try and run this test for me? The coolest feature is the Buster server. This sets up a server on localhost, listening on port 1111. You can then point lots of browsers at that server, and you get a page which says capture this browser. You press the button, and the Buster server will take control of that browser at that point, that browser window. So you can have Chrome, Chromium, Firefox, Opera, your iPhone, your Android phone, all pointing at one instance. And then whenever you run Buster test within your project, it will remote control all of those browsers, run the test suite on them, and return the results back to your console window. Really, really cool feature. JS Test Driver does do that at the moment, not quite as cleanly as Buster, and it's a big Java app that requires particular setup for it. So definitely a really promising tool to keep an eye on. And I've just squeezed it all in. Thanks a lot. Thanks for your time.
Given that we're running a bit late, we've still got plenty of time for questions. Is this making sound? Yeah, cool. So anyone got questions for Malcolm about JavaScript testing? Cool.
It's not so much about testing as about debugging, but you might know in Node.js there's a convention to make any error the first argument to a callback, so you can inspect the stack more easily.
Okay,
So,
I didn't know that in Node.js because I haven't done any much work with it.
If you don't know about that, it's probably not relevant. I was just wondering whether you'd tried that on the client side at all.
No,
Right.
no, sorry.
Hey, anyone else?
So I've actually done this recently at work, like last week. I got Selenium running with QUnit and Sinon.js. I didn't use Jasmine. Have you tried the mocking and stubbing in Sinon as well? Do you have an idea of the comparison?
Jasmine has got spies and stubs and mocks built into it. They're not as powerful as the Sinon ones. So the Sinon ones, you can control the behavior of the stubs. For example, if it gets called with an argument, then do this. If it calls with another argument, then do something else. That's really useful. And you can also say, the first time this method gets called, do this. The second time it gets called, do something else. It's just a lot more powerful than the Jasmine built-in mechanism.
Anyone else? Okay, if nobody's got any more questions, please thank Malcolm for his talk.
Thank you.
Okay, we'll just take a moment or two to swap our presenters over.
Is that good?
That sounds pretty good to me.
Awesome.